Finding files by names is a pretty common thing for us to want to do, but we also have the ability to find files by what's inside of them. And that's often something that we want to do in terms of being able to search for something like a source code file that has an expression in it, or to find some file like a markdown file that has something that we've written in it that we know that those words are in it, and we want to be able to find that information. We're going to use a tool to do this called Grep. Grep is a very badly named tool. Where find is something that I consider to be discoverable. It's pretty easy to figure out what find does based on the fact that it's called find. Grep is not. Grep is not. Grep comes from a command in an editor, a text editor that's called ed. This is something that was popular decades ago, and the grep command in ed is globally search for a regular expression and print matching lines. That's kind of a mouthful. Regular expressions are something that you're going to see in a course that's called Comp 3030, and that is automata. Um, and it's a 3000 level theory course at the U of M, and this is the place where you're going to see regular expressions. Grep is a program that will basically let you find lines within a file that match a certain pattern. And the patterns are almost the same as what we saw with find. We're going to be able to use things like asterisks and character classes and question marks. But we're also going to see the ability to use a couple of other things. We're going to start this example by getting some more data. So we've got a couple of files in this folder right now. We've got a directory that's called comp 1002. We've got crazy directories. We've got hello. We've got tools and techniques, so the textbook. We're going to come back to the crazy directories folder a little bit later, but for now, we're going to start with getting a new file. So I'm going to use wget again, and the file that I'm going to get this time is tools and techniques .ca/topic 05, and the file that I'm going to download this time is called covid.fasta_simulated.fq.gz. So this is a file that comes from the NCBI, the National Center for Biotechnology Information. This is an organization that's in the US, and they host a lot of genetic data from scientific research, from microbiology research and public health related research. This is from an isolate of the COVID virus, and this is something that has reads, sequencing reads. We don't really have to be microbiologists to understand what's going on here. I don't really need us to know anything about COVID or sequencing or the NCBI. I just want to have a data file that looks a little bit different than what we had been working with before. This file is a gzipped file. So where tar and zip files can contain directories and files, a gzipped file contains just one single file. There's no directories in here. This is just a compressed single file. We can unzip this with gunzip and then co, and then I'm going to press tab here, and then v, and then press tab. So I'm going to gunzip this file. Where tar and unzip will keep the file that we had originally, gunzip will remove the file that we had originally, and it will just decompress it. So now there's no .gz extension there. This is now a gunzipped file, or as we normally call it, a regular text file. Let's take a look at this text file. I'm going to use something called a pager to take a look at this. Pager is a program that will let you scroll through text files one page or one screen here at a time. So I'm going to say less is the name of our pager, covid.fasta_simulated.fq. This is a set of reads in a format that's called FASTQ. Again, we don't really need to know too much about this other than to know that each of these blocks that we have here that starts with an @ symbol and then goes to the next @ symbol, this whole thing is what we will call a single record in this file. And it's common for microbiologists to want to know things like how many records are in a file, or what are the records that are in this file. Records in all of these files, again, start with this @ symbol. The stuff that comes after the @ symbol here is a human readable identifier. So this is something that we, me and you, will use to understand approximately what that thing is. What follows that is the sequence data. So this is ACGT. This is the genome information for a virus or an organism. Then there's a plus symbol all by itself on a line. And then what follows that is going to be quality information. So this is a physical process that takes a genome and breaks it into lots of pieces and then runs it through a machine to digitize it. And the machine is able to know a little bit about how good of a job it was doing when it did that transformation. Again, this is kind of irrelevant for what we need to know about. The only thing that we really need to know about is that this is a text file that has lots of records in it, where we may want to filter those records, or we may want to be able to count those records very quickly. And there's so much data in this that it's not really reasonable for us to do this by hand. So for us to go through this one line at a time or 10 lines at a time and count all the ats, it's just too much data for us to use. I can quit less, and kind of the same way that I quit Vim, you actually notice that there's a colon down here. I can just press the Q button to quit less. So the basic idea with grep is that I can filter lines from a file. So I'm going to filter lines from this file. So I'm going to say grep. What I pass to grep is two things: the pattern that I want it to filter, and then the name of the file. So COV tab. So I want grep to print out all the lines in this file that have the @ symbol anywhere in them. I press enter here, and what this does is it prints out all of the lines that have the @ symbol in them. This is really good, and with FASTQ formatted files like this, the @ symbol is usually only going to be at the beginning of a line. It's unlikely for it to appear anywhere else. But we can also use something called an anchor to say that we want this to appear only at the beginning of the line. So the anchor for this to appear at the beginning of the line is the hat symbol, or the carré symbol, if you were thinking about this as a French language thing. But I think that I like to call this a hat instead. This is the character that you get when you press Shift and then 6 on your keyboard. This says this symbol here is the beginning of the line, and so this must be the first character on the line, and it must match this pattern for us to be able to print this out. If I run this, the output from grep is going to be pretty much the same as what it was before. We are still getting the same lines because, again, with this format, all of the files, all the records are going to start with that symbol. This is useful, but you can also see that this kind of scrolls past the beginning of the page that I have here. And so we also usually want to be able to count the number of lines that match this pattern, as opposed to actually just seeing all the lines that match this pattern. Grep gives us the ability to do that by passing another flag. So -C for count. This is a lowercase c. And again, kind of like find, kind of like pandoc, this is another program on the command line that takes arguments or flags, and it uses this dash symbol and then the thing that we want it to do. So -C for grep is going to say, I want to count the number of things that are in this file. So in this file, there are 1187 lines that match the pattern. At the beginning of the line, there's an @ symbol. This is useful, but we also sometimes do want to be able to see information within the file itself. And the way that we can find some information about the lines around it is to give us some context. So like print out lines that are before the line that matches and print out lines that are after the line that matches. So I'm going to say -A here, and this is going to say I want to print out lines that match this pattern And I'd like to print the line that matches this pattern and also the two lines that are after the line that match this pattern from this file. So if I press enter here, what we're going to see is it prints out the line that matches that pattern. So this line started with an @ symbol, then it prints out the two lines after that. So it prints out the record data, the genetic data that we had, and then this plus symbol that was the next thing after that line. And then each of these records is going to be separated. So the separator here, the two dashes here, is coming from grep itself. The two dashes are not actually in that file. I can print out the two lines before it using uppercase B. And so now this is printing out each of the lines that match this pattern, an @ symbol at the beginning of the line, plus the line before it, and the line before that. And then again, grep is printing out these two dashes to separate these things for us. I can also put context of both before and after using the uppercase C. So lowercase c gives us count, and uppercase C gives us context of around the file itself. So if I do this, it prints out the line that matched, the lines, two lines before it, up two lines, and two lines after it, like this. The other thing that we can do with grep is that sometimes we don't necessarily have a specific directory or file. We don't have a specific file that we want to filter lines on, and we have a directory instead. So I'm going to change into this crazy directories folder here. Again, this is the one that we were using find on. What I want to use now is I am able to find files by name from this directory. So we were able to do this, find name star.md to find all of the files that had this markdown extension. But now I want to, instead of finding things by markdown extension, I want to find files. So maybe I want to find files that have a markdown extension, but only have emoji shortcodes in them. So emoji shortcodes usually look like this. They have a colon, they have some word inside of it, and then they have another colon at the end of it. The way that we're going to do this is there are no files in this directory for us to be able to search, but grep has an option on it that we can say -r. So this is reminding us of way back closer to the beginning of the course where we looked at the rm command. The -r option here says recursively, I would like to descend into each of these directories and each of those directories and each of those directories and then find any file that matches this pattern. So I'm going to say -r, and what I'd like to filter on here is the pattern that is any line that has a colon and then anything and then a colon after it. The difference between the way that I was running grep before and the way I'm running grep now is that because I'm passing it this -r option, I don't pass it a file name. I just pass it the pattern that I want to find. So what we get back from this is there's robot. It's got several different lines that have this colon, this emoji shortcode pattern. There's bananas. And then there's two other things here, docx file, and a docx file. Docx files, for the record, are actually just zip files. So if you unzip a docx file, you're going to find that there's a bunch of other stuff in there, including XML files. These are another way to structure data. So Markdown and LaTeX are two structured formats for writing text. XML is another structured format for writing text. This is useful to be able to find these file names that have the patterns, but sometimes the file names themselves are a little bit too long for us. Not the file names, but the contents of the file are a little bit too long for us to be able to find that in. So sometimes we want to be able to see not just what the file names are, but where they are in the file names. So if I add a -n here, I want to print out the line number. This is going to print out not just the name of the file, so robot.md, but it's also going to print out that it's on line 6 that it found a robot, and on line 10 that it found this mechanical leg. This is useful for when I want to do something like this. So I want to open this file in my editor, so R3T, and then robot.md. Here, well, I mean, there's only 10 lines, so we can see it pretty quickly, but I can go to a specific line in Vim in normal mode. I can press colon, and then I can just type in a number, and it will take me directly to that line. So you can see my cursor is now on line 10 here. So while grep is not a discoverable name, it's a pretty powerful tool to be able to help us search within files in a way that we kind of actually can't really do with Finder and Explorer. They start to get us there, like they are able to find things within certain kinds of files in Windows and Mac OS, but it's kind of limited to what they're able to understand. Grep is able to just kind of like look through everything and tell us if it's able to find a file that has a certain pattern in it. The patterns here kind of look a lot like what we've seen already. And so that's nice to be able to reuse this idea from place to place.